Hello, hello. Oh, and I forgot to change to my other video too. I don't even know if it's on. It's all good. Hello, and welcome to our Merge PHP. There we go. Okay, turning that off so we don't get echoes. I should be good. Okay, so we have, this is my first time presenting and finding everything, so bear with me. Thank you for your patience. I appreciate it. So to start off with, we're welcome to Merge PHP. We're a group of PHP user groups that are sharing some of the load online to do events. And we meet on the second Thursday of the month at 7 p.m. Eastern and 4 p.m. Pacific, which is a little bit later than earlier than what you're joining us today. And let's see, our user groups, maybe. Uh-oh. Okay, there we go. Here's our user groups. Do we not have all the other, or did we not? I don't know what's going through this. There's more slides with individual groups, but are we jumping through? I guess this is a slide you see here. So if you are looking for JetBrains license, please email chris@atlantaphp.org. You can win a free JetBrains license. It also lets JetBrains know that we appreciate them, so don't feel bad about that because we do appreciate JetBrains. Many of us already use JetBrains. I will be doing demos on JetBrains PHP Storm today. So if you're interested, please do email chris@atlantaphp.org there for a chance to get your copy. Oh, here is our PHP support. Just to remind you that you should be upgrading PHP so that you are not having to worry about security, and also because of speed. We're going to talk a little bit today about performance, and one of the best things you can do for your performance on PHP is actually to upgrade your version, because one of the things that they do in the upgraded versions is optimize things. So you can get speed optimizations just by increasing your PHP version. So make sure that you're doing that. Also notice that when end of support is, like, you don't want to get out of security updates because that's important. You can always go to the php.net website to find the latest PHP versions and when support lasts, and all of that is for you on php.net. If you are not on 8.1, you are already out of support. If you are on 8.1, you have until the end of the year to upgrade. So we are now at 8.4, so you should be upgrading. But upcoming conferences. Ooh, Longhorn dates, yay! Hooray! We have PHP Day in Verona, Italy, PHP Conf in Istanbul, and PHP Tech in Chicago, as well as PHP Belo Oeste in Santa Catarina, Brazil. So lots of things going on in May, hopefully somewhere around where you can join. Please do try to go to a conference when you can. Those are the ones coming up. For those in the United States, as most of our meetups are for Merge, your conference coming up is Chicago, PHP Tech on May 20th through the 22nd. So it's really a great opportunity to meet people from the community and learn and expand your skills in your network. Really a great time. And people are awesome. So if you can make it, really do try to make it. And if you need suggestions or help on how to talk to your employer about paying for it, or any of that stuff, reach out to somebody in the group. You can post in on YouTube even. Someone we'd love to see what we can do to help you get to the conference. Other conferences coming up, we also have more you see here. International PHP Conference in June, Web Summer Camp in July, LarryCon in July, Laravel Live in Denmark in August, API Platform Conference in September, and Longhorn PHP just announced dates for October 23rd through the 25th. So we're really excited about that because Longhorn, the Texas PHP group, is also part of Merge. So lots of people that are here are two big conferences here in specifically for PHP in the United States are PHP Tech in May and Longhorn in October. So hopefully we'll see you at one of those. And if you like Laravel or you're even interested, they usually have a great conference as well, and that's in July. So that's a specific framework specific, but always a lot of good PHP talks as well. So if it's easier for you to get it to Denver, join some community in person. It will definitely be fun. Okay, if you want to be social with us, besides just typing in the YouTube comment box right now, you can find us at most of the social media places. We're somewhere as Merge PHP. So if you are on Mastodon or Discord or LinkedIn, or I think even the former Twitter, we're there. So please join us and share what you're doing, what's going on, questions that you have, become part of the community, jump in. Maybe. Okay, our next month's talk is going to be on HTMX on May 8th. So put that on your calendars now, and we will have that more details up for you on the Merge PHP website shortly. Okay, and finally, before we get started on tonight's, if you have talk ideas, something that you would like to do, if you've wanted to give a talk before, you have something you want to share, or somebody that you know has done a talk that you've heard before and you would really like to share that on Merge PHP, go ahead and go to this link right here and fill out our speaker form and give us your suggestions, and we will reach out, whether it's to you or somebody else that you are referring. They would, I'm sure, love to say, they can still say no, but it's nice when somebody says, hey, this person did a really great presentation. I'd like to share that with more people. So don't hesitate to suggest someone. Doesn't force them into giving a talk, so don't feel bad. We don't force people. And then tonight, we're going to have some heaps of fun with PHP. I'm going to be showing you some code and showing you some resources that you can do. PHP has some really great functionality, and I actually want to really highlight that tonight, that a lot of the built-in functionality that you've probably already used is actually very performant. And as I mentioned in the upgrades, if you are staying up to date on the latest PHP versions, you're also getting that boost as they are optimizing code in the back end that PHP runs on. So definitely do that for performance. And we're also going to talk about some different data structures that you may not be using that may or may not be helpful, and when you may or may not want to use it. So the goal for tonight is to help you experiment. This is really to give you a jumping off point that might give you some options to go a little further in PHP with algorithms or computer science stuff that you go, hey, that doesn't make sense with what PHP does. Why do we do this? Well, sometimes the answer is because PHP makes it easier and you don't have to worry about all that jargon that some of the other languages make you do. We can just rely on some people, smart people who've already made some things for us. But there also are ways that you can use some specific data types that PHP has, especially in the PHP standards, the Standard PHP Library data structures that you may not have used before. So let's jump in, see if I can share some other tabs. I really want to share tonight that Doken, I hope I pronounce his name right. He has some great articles that really walk you through all of this. So I will make sure that you have this at the end, but definitely go check out his articles that talk about some of the different ways to do data and the data types that we have and why or why not. So we're going to be going over a lot of this tonight, but these articles will let you jump in more directly. And I love to work to share people who have already put in a lot of work to give you a lot of information as it is. So the first thing we're going to jump into is some terminology. I always like to define some terms first. So today we're going to be talking about two major things. We're going to be talking about data structures, which are the types of data you have, the way that data is stored. And then we're also going to be talking about algorithms. So you've probably heard a lot of crazy talk about algorithms, because there are definitely some crazy algorithms. Oh, I was going to show. I will share some later. Not every algorithm is actually an algorithm that you want to use. So just to start off with, I want to put that out there. But let's define what an algorithm is and is not. So an algorithm is the process or the set of rules to be followed in calculations or other problem-solving operations, typically by a computer, but we do this all the time. I did not get good slides for you here, sorry. As an example, an algorithm are all of those steps that you would go through. So let's take a recipe, for example. You want to make a meal. You're going to bake something. You have the whole recipe is your algorithm. You follow all of the steps. And if you follow the steps exactly, and there are the same inputs, you would get the same outputs. If the inputs change, the outputs are going to change, but it would still be following that algorithm. So that's what an algorithm is, but there are some other terms that jump in when we see algorithms. We're like, is an algorithm a formula, for example, or a procedure, or is that the function? Like, oh, we set up a function and that's my algorithm. Well, the algorithm solves the actual problem, whereas the formula is the tool that's used in the process. So for example, in our recipe, the algorithm is the whole recipe, whereas the formula is the ingredients that go in. You need 2 cups of flour, 3 eggs, a cup of milk, etc. That's your formula, where you have the number of something and that thing. That's your formula, your ingredients. So what's the difference between an algorithm versus the procedure is the algorithm is a general abstract set of instructions to solve the problem, where the procedure is the specific concrete implementation of the algorithm. So that's often like when you have a class and then you instantiate the class, you actually have an object that was created from the class. So your procedure is the actual thing that is done that follows the algorithm. And then the algorithm is a set of functions or steps to solve the problem or perform a task. And then the function, there could be functions that you do, or your algorithm could be written into a function, or it could be a recursive function. So those are all different words that are around algorithms, but not necessarily the algorithm. The algorithm is a set of instructions or steps to solve a problem or perform a task. Like, what do you need to do to make a peanut butter and jelly sandwich? Those are algorithms that you've started out, that they often start out with, even in elementary school. The other terminology that I really want to make sure that people understand up front before we get into any algorithms is that recursion. Recursion is when you have a function, when you're going to do the same thing until you get to an answer. Like, you might do this with a loop. A loop is a simple recursion. You're going to loop over something until when you loop and you remove something, and then you loop and remove it, you loop until it's empty. That would be recursion. Just like with any other loop, you want to make sure that there's a way that we get out of recursion. But something that happens until something else is true, or for so many iterations, we might do the same thing over and over. So it's a smaller set of our functionality. Part of the algorithm is often used with recursion, and we'll see some of that. Okay, so let's jump into some of the I do like HackerRank. Many of their challenges do allow for PHP, so that's great. There's a lot of things that you can do there, and that's a great way to test some things out and try some different things that you may not have necessarily run into, but you may run into in the future. Okay, so to start with, one of the basic things let's talk about some basic PHP. Let's see, we don't want, those are data structures. We want our basic data structures. Okay. I didn't show you basic data structures. I was going to show you basic data structures. Okay. Okay, there we go. Types. Let me share this tab. There we go. Our basic types. So in PHP, you've probably used a lot of the basic types. We have booleans, integers, float, strings, arrays, objects, and even some things that you may not have used as often, like singletons or iterables. Okay, many things fall under iterables, including arrays. Other resources. So these are some of your basic PHP variable or data types or data structures. In PHP, our basic data structures, one of the major structures we use very often are arrays. And PHP has a lot of options for creating your arrays, and it's done a lot of optimization in the background for us already when it comes to arrays. We have hashed arrays, numerical arrays, all kinds of arrays and ways that we can store in an array. So first thing I want you to know is that PHP arrays are actually very performant. You can definitely do some weird things to make them not so, but there's a lot of things that go on in the background to make arrays very performant. So don't be afraid to use PHP arrays, but there are also some different data structures. So some of the data structures that in the SPL library that you might not be familiar with, for example, one is the fixed array, the SPL fixed array. Now, every once in a while, if you're actually not changing your array. If you're not going to change your array at all and it's staying the same, then your SPL fixed array can actually be more performant. It's an array, but it sets up all of the memory for it right off the bat, and you don't actually change it. You're not changing where it's stored. Whereas in PHP, you don't typically say how big your array is going to be right off the bat. You may add things or remove things from an array, and that's typically good because that's a useful part of an array. But if you already know everything that's going to be in your array right off the bat, and you just need to do things with it, your SPL fixed array could actually give you a little bit more performance on that. So it's going to work a lot like your other arrays. It's just going to set memory to begin with, and so be a little bit more performant. The next thing I want to talk about in our data structures is linked lists. So linked lists are a lot like arrays because arrays are basically a list of things, whereas a linked list, again, is also a list. It's just stored in a different way. So a linked list, let's share this instead. Okay, so our linked lists have a singular linked list has a pointer to, there's a list that has a head, and then they have different nodes. And that node tells you about this item, and then it links to the next one. So the node itself only knows about the next item in the list. It says this is the next thing. So with a linked list, with a single linked list, we link one direction. So our list stores the head, and each node shares the next node in the list. My next node is, if we were doing the alphabet, if we were doing a linked list in the alphabet, our first one is A, our next is B, and that's the next item. And then B would know about C being the next in the list. In here, this example gives you actually creating a single linked list. And I do have this as an example so that we can show. I can also just going to show you on. He has a GitHub repo that you can go and see. I'm not going to go show you too much of this because this is like setting up our own data type, setting up a linked list. We have our linked list. It knows how to change the node, and these are the functions that it's going to do, whereas our node itself just knows about it and the next node. So in our single linked list, it's going to know, we can set it up to append. It's going to know one or after. This will give you an idea of the code that is used. You don't actually have to write this code because PHP has, oops, that is not the right, it has the doubly linked lists. That means that your node knows about the node after it and the node before it. In this way, we can traverse that list. We can go back and forth in that list, either forward or backward. So if you need a list of things and you want to be able to travel, or you want to be able to add things into the list and be able to go from one to the next, and it's a simple list, the doubly linked list can be useful for you here. You can see, you can count, you've got the top and the bottom, you can add, you can get a key, you can see if it's empty. It's going to have a lot of your functionality of your array, but it's a simpler format that can be, it doesn't need to store the whole array in memory. So it can be a lot more performant if it's just showing working with part of it. So if you're looking for performance and you just need to go from one to a next, doubly linked list. Something that builds off of the doubly linked lists are your queues. So this is something that you might actually use more so when you're creating something. You want to create a queue of things that go in and go out, like first in, last out, first in, first out, whatever. You're creating a queue. It's like waiting in line. Great. We've got all these people. You take your number. You're in line. You're in this queue. So queues are a modified feature of linked lists, and that's why they're actually very useful if you're going to be doing some sort of queuing. If you get more into one of the queuing libraries, they're going to be built on some sort of linked list idea. So this is a really good place to go if you're looking for something like that. Now that we've talked about lists, I want to get into talking about trees. Now, our tree structure is another basic structure that you'll see when you're talking about computer science or in algorithms or something like that. You're going to have different types of trees. Trees are a type of graph. So if you talk about graph theory, they're going to be in that type of thing. So a tree is a simplified version of a graph. Typically, graphs can connect to more pieces, where a tree is just top down. Its children only connect back up to the parent. They don't connect to their siblings. And that's the big difference between a tree and a normal graph. If you want a nice picture, share this tab instead. Oops, there we go. Because pictures are worth 1,000 words. In a graph, it's typically cyclical, but it doesn't have to be. A tree is not, or is acyclical, meaning that children don't know about their siblings. They just relate to the parent. So there are different ways. Where are our types of... Okay, so if we want to traverse a tree, there are a few different ways we can do this. And we're going to get into some code and actually run some code for you. So first off, the first thing we can do is a depth first traversal. There are a few different ways, and there are a few different types of depth first. But what depth first means is that it means we're going to go as far down on the tree as we can, and then we're going to work our way back up the tree. So again, like I said, these algorithms are recursive. That means we're going to do the same thing. We're going to go all the way down, and then we go back up, and we're going to have to do that same kind of loop back up once and go back down and up and down and up and down. So we'll see some of that recursion and when it comes to traversing a tree. So with a depth first, we're going to go as far down as we can and then go only up a little bit until we can go back down. So there are a couple of ways to do this. There's the pre-order, in-order, and post-order. Here's a pictorial representation, and then in code, this is what your tree is going to look like. If we were to kind of represent this in code, we can see that it has a value of 4, and its children are the 2 and the 6. The 2 has 2 children, the 1 and the 3, and the 6 has 2 children, the 5 and the 7. So in the pre-order traversal, we're going to go to the node left and then right. So when we're traversing a tree, we start at the root node and then we apply the algorithm. That's how we traverse the tree. In a pre-ordered algorithm, the node will be visited first and then its children from left to right. So this process is recursive because there are multiple child relationships here. So we're going to have to do that same part of it multiple times. So with this, if we saw this tree here with the 4, 2, and 6, and then 1, 3, 5, and 7, with the pre-order traversal, the output is going to be 4, 2, 1, 3, 6, 5, 7. So what we're doing is we're going 4, 2, 1, then we go up just enough that we can go down another one, 3, we go up, there's nowhere else to go, so we go up and we can go down to the next one. So then we go 6, 5, 7. So that's how this is going to be traversed. That's how we're going to travel through our pre-order. So our pre-order example, it's going to say, this is our function so that we can recursively go back through the function. So we say our output is the node we visit. We add the output because we're doing the node first. And then we're going to, for each of its children, if it's empty, then we're not actually going to do this for each loop. That's what this is saying. If it's a children or an empty array says move on, we just skip this. And it gives us a way to not test if there are children or not. And then it's saying, hey, we want to put some more output, but to get that output, we need to put our child now into the pre-order. And the pre-order is saying first thing we do is add the node. So that's where we added that 4 and then the child's 2. And then it says to go down and it says we have children again. So we added a 2, we added the 4. So we first went to the 4, then the 2, then we went to the 1. And since we got to this loop and there are no children, it's going to skip over there. And we're going to go to the next child. So it's then going to say, okay, it's doing the next child because it's going to the for each. It's still in the for each of that number 2. So we are on number 2 and we did to the child. That loop's done. So we go back to the next child, which is the 3. And then that loop's done. So we go back up to the 4 and go to the next child of the 4, which is a 6. So that is our pre-order traversal. And it's this recursive function that it's going through to get that parent and child relationship. The next way to do it, traversal of our tree, is in order traversal. We do the left node and then the right, the left, the node, and then the right. So this is typically an algorithm that you're going to makes the most sense for a binary tree, because we go first left and then visit the node and then go right. If you had more than that, you'd have to figure out what you do with the third one. You can't do, if you have more nodes, more child nodes on that portion, this one doesn't really work. So this is typically only used in a binary tree. So you would go to the left first, then back to the node itself, and then go right. Running the algorithm would produce, would produce 1, 2, 3, 4, 5, 6, 7. So let's show it on our picture again. So it's going to go all the way down. So it goes down and it goes 1, it goes to the child, then the node, then the right child, and then the node, because it already did the left, and now it's going back up to the node. Now it does the right, which is here, and then we can still go down to the left, so it goes down to the left first before it does this node. So we do 4, 5, and then the node, and then the child. So we're actually going from here all the way down to 1, to 2, to 3, and then back up to 4, then all the way down to 5, 6, 7. And that's how it is being traversed in the in-order traversal. So to do that, our function looks like we either have we're only doing 2 children, because this is really only works for a binary tree, which means it has 2 children. And there's either a left node or it's null. And then there's either a right node or that one's null. And that's it. Those are the children that it has. So if we have a left, then we're going to actually do something, because we still want to go down. So we're going to go all the way down the left side until we're done. So if we visit the node itself, then we hit the node and we output that. And then apply the algorithm on the right side. So if we've already done, we go all the way down the left, and then we visit the node, and then we apply that same algorithm to the right. We go down to the right. And then again, we'll output. So that's how we get, if we're doing our in-order traversal. The last way of this traversal is the post-order traversal. And in that, we're going to go left to right and then the node. So in the post-order traversal, we'll visit all of the children first from left to right, and then the node itself. Because of the recursion of this algorithm, the output will be 1, 3, 2, 5, 7, 6, 4. So we back up with our visual. We're going to do the children first from left to right. So we go 1, 3, 2, then we go 5, 7, 6, and then 4. So in this case, we're going to look for the children first, and we're going to recurse around that, and then we're going to visit the node. So children first, and then visiting the node. It's very similar to our pre-order, but we visited the node. We visited the node first, and then visited the children. In the post, we visit the children, and then visit the node. So this is our depth first tree traversal. This is where we go all the way down and then come back up. The other way to do that is a breadth first traversal. This is typically what you're going to use if you don't know how deep it is, or if it could go very deep. For example, if you're going to be following all of the links on a website, when you have to say, oh, only go so deep, this is what it's doing. It's doing a breadth first tree traversal. So the level order is pretty much the same as the pre-order, but because it's breadth first, we actually visit the child nodes before visiting the next level of child nodes. So first we'll visit the root node, which was 4, and then its children, which are 2 and 6, and then we'll go to the children of the 2. So then we have the children of the 2 and then the children of the 6. So in that case, the level order traversal would be 4, 2, 6, 1, 3, 5, 7. So let's go back up to our visual. First, we would go to a 4. Then we would go to both of its children, 2 and 6. And then we're going to go to the children of 2, which would be 1 and 3, and then 5 and 7. So we're going to get 4, 2, 6, 1, 3, 5, 7 in our breadth traversal, as we go wide first and then go down. So this is really useful when you want to be able to stop. Like, hey, we don't want to go all the way down. We're just going to go till we get to a certain level or a certain number. Hey, maybe we only want to follow so many links or whatever. This gives you a lot more control of that type of thing. This would often look like a structure for a book. You'd have your chapter and then your subchapters, things like that. And then, like I said, the breadth first would be like indexing a website. Okay, so now that you understand a tree, we can get into heaps. Heaps are just a little bit of an expansion of a tree. So we're going to be able to do a lot more with a heap than we would with necessarily a normal array, because with a heap, they're always going to be ordered. A heap is always ordered. So if you need your array to be ordered all the time, you could use an array and sort it every time you order it. Or if you use a heap, every time a new item gets added, it will automatically sort it to the correct spot every time. So a heap is a binary tree because that's how it can follow through the structure. So since we know how a binary tree works, as you add stuff, it's going to rotate things to move it in your binary tree. And the nice thing is that PHP has I did not share this one instead. Okay, so heaps are heaps here. Heaps are a binary tree, but they're always sorted, and they'll sort for us. A heap is a complete binary tree. So we talked about trees. There are different types of trees. Your main tree is a binary tree, but there are also 5 different types of binary trees. A heap is a complete binary tree. That means every row of the tree is filled from left to right without leaving any gaps. And then anything that's empty is on the far right. So if there's no gaps in it, but there could be, maybe if you have less, if you have an odd number, you're not going to have that very last node or leaf on your tree. The right-hand leaf is not going to be there. So with a full binary tree, that means every node has 0 or 2 children, but never 1. And in a perfect binary tree, every node has exactly 2 children. In a balanced binary tree, the left and right sub-branches of a node never vary by more than 1 node. So it doesn't, you can't go down 6 levels on trunk number 1 and then only 2 levels on trunk number 2. Doesn't they stay balanced, never too far out of balance. In a degenerate binary tree, every node has a single child, essentially making it like a single line list. And then the complete binary tree, which is what a heap uses, is when every row of the tree is filled from left to right without leaving gaps. And that's why we can actually have that order stay the same all the time, because as you add one, it knows how to change the list and where to put it. So you could do this yourself. And there is some code samples of how you might do this. But as we looked at the samples from the tree already, it's going to work very similar to the same way. But instead, we are going to want to use what PHP already has built in. So PHP has the SPL heap, and you have your two choices. Your heap is either going to be a max heap or a min heap. And that's based on which one is the root node. Oops. So here we go. So we have our base class, and it's extended by either the max, the min, or the max heap. So with an SPL min heap, that means that the root node is the minimum, is the smallest. So the root is always going to be the smallest. So the first is going to be the smallest, whereas the last is going to be the largest. So depending on how you want to add and remove things, is which one you want to use. So back here, okay, so I'm going to show you some code and why this is actually really useful. Let's see if I can stop present. Stop screen. Let me see if I can share my present. Share screen. Oh, nope, I can only show. Okay, we'll try it that way. Okay, I can share my entire screen, so let's try that. Okay, so, oops, not the linked list. Got some code for you here, but our heap. Okay, so here's an example of two ways to do this. We want to make sure that everything in my list is above a certain number. If it's not, they need more. Or we can do, so we want to grow our heap so that every value in the heap is above a certain number. So we can do this first. If we looked at this as an array that you're probably used to, we have our array. The first thing we need to do is sort the array so that we know that the first value is our smallest value. And then if that first value is already bigger than our growth limit, then we're going to say there were no steps. We didn't have to make any changes. So our steps, and that's done, and we're done. So if we don't actually have to change anything, we're done. We made no steps, nothing changed. It's going to stay the same. If that first one isn't, this is where we're going to put whatever calculation. This would be whatever functionality you need to manipulate those numbers if they're not there. Maybe you multiply the number by itself. In this case, we're taking out the first two, and we're adding the first one plus 2 times the second one. So if the first number was 2 and the second number was 3, it's going to say this is 2 plus 2 times 3, which is 6. So it's going to be 2 plus 6, which is 8. And so it's going to add 8 back to the array. And because we don't know where 8 falls in our array, we then need to sort our array again so that we make sure that next time we loop through here, it's pulling that first number. Now, if we want everything to be above 10 and we're at 8, well, that 8 may still be the first one, or it may not, but we're going to get to that 8 again. But we have to make sure that we sort it every time because we want those smallest numbers. And then we're just saying end. And if the array is, if the first array is greater than the number, then we return our steps. If we got to the last array, then a last item in the array, and it's still below our limit, then we're going to return our 1. So let's run this script to see to show what we're going to get here. So we have I'm just passing in some data here. We're going to say, this is my data. Everything has to be over 100. And here are my different numbers that I'm passing in. So on this works just fine. You can see it worked really fast. We don't have too many numbers. It's fairly efficient. PHP can handle it. But when we get up to data 2, we want everything to be above 1,059,589, and we have a lot more numbers. Okay, so what happens now when we try to go through the array and we put in that data? So as you can see, it's already lagging on my machine. Our first start was 9. I'm still waiting because it has to perform a bunch of calculations. So it started out with 9. It ended with the first value being above that 1 million that it needed to be. And then it had to go through this 17,595 times. And it took 9.64 seconds. So that may be a rough time and not what you want to wait for. Most of the time, you don't want a calculation that's going to take 9 seconds. So what can we do to go faster than that? Well, having to resort it every time, we could write something that bubble sorted it, put it to the next one a little bit more calculated ourselves, but a heap already does that. I'm going to first show you the output with the heap, and then we'll look at the code. So if I run the same thing, I just ran the same data. Oops. And I did not, this doesn't look formatted quite right. We'll change that. So the time that took was less than a second, much less than a second. This was way faster. And that's because a heap is designed to do this sort of thing where it keeps the new values sorted. And you can do that as you want to do things to a bigger number or the smallest number, and you're adding things. This is where that heap can come in handy. You can do custom things to that heap. So let's go back through our heap. So here was our grow array, and now here's our grow heap. So first thing, I took this array and I changed it into a heap. I created this heap. I just wanted to make sure that it gave the same timing challenge. So before we set our timer to go into the heap, I wanted to make sure we already had our heap to start with. Didn't want to make that. You can definitely move this around so that you can see, creating the initial heap. Did that take so much longer? No, it didn't, but you could try it out and see how it worked. So we created our heap, and we're going into the heap. So instead of an array, we're going to go through the heap. So we're echoing our top. So we actually want to change this to start first. And instead of you'll notice here, instead of using the array syntax where I called this as the first value, we have to say it's a top, much more like an object. So we did the first, and we said if that top one, just like if our first value is already greater than our minimum growth, then we're going to return our 0, or else we're going to go into our steps. And we're going to end first and do okay. So with our heap, we say while the count is greater than 1. It was very similar to our array count. We counted our array, but here we do, we call the count is greater than 1, and the heap top is less than our minimum growth. Then we're going to go through we're going to add a step saying, yeah, we've made one step into here. We've taken that first one. We do the extract, which takes it off. And as you'll notice here, we did a min heap. So this extract is taking it off the top. So because that's what we're working on here, if we had made this a max heap, the top would have been the biggest number. But we're starting with the smallest number. We want the top. We extract from the top. So we extract the first 2 from the top, and we're doing the same thing. We're adding the first one and 2 times the second one. And we're inserting it back into the heap. This insert automatically moves that for us into the right position because it always stays sorted. And then what we can do is echo out, again, the first heap to know, and we're returning either we made it all the way through and we have so many steps, or we didn't and it's a -1. So again, we're just doing our micro time here. And as you can see, let's run it one more time now that I fixed my output a little bit. We have our start first was 9. We ended with over 1 million because that's what we needed. And it took us 17,595 steps, which was the same as this. If you'll notice it's the same as the array. We did the same number of steps. This just did it much faster. We had the same number of steps, and it was over 9 seconds with our array, but it was less than 1 second with our heap. So if you're trying to do something that is requiring you to do something specific that's changing the value, making sure that we're using the right data structure is useful. So in this case, the array was not as performant as the heap because it needed to sort. It needed to keep sorting that every time. And as you noticed, that was fine until we got to a much bigger number. We had a higher number of our growth, and we had a much bigger number of input. So sometimes this is helpful. Sometimes it's not. Sometimes we don't want to optimize too early. Don't use a heap when array is going to work. You already have it in an array. You're doing other things with the array. Possibly you don't necessarily need to have it in a heap. If you're not crunching millions of numbers and you don't need to have it sorted, your array is probably going to work just fine. And it's going to be a lot easier to use. But if you do need to do something where you need to keep it sorted, but you're changing things that come in and out, whether you're doing things or not, you're just adding new things, and it needs to sort every time. If you want to keep it sorted, A heap will help you automatically keep it sorted no matter what you're doing. So when you run into an algorithm that's saying, hey, to do this, as we had here, this was our part, these were our steps. We want to, if the value is already greater than this number, we're done. If the first value, if our lowest value isn't, then we need to grab the first two values and do something with them and add them back into our list of numbers. So in that case, we're doing this algorithm, while it works, as we saw with an array, when we use the correct data structures, it worked a lot faster. So my big tips, takeaways from this are there are a lot more data structures than you may have used in PHP, but most of the time you're not using them. If, for example, you're working in queues, there is a data structure for queues. You're probably better off using a queue because it has optimized for use as a queue. Again, if you're wanting to keep things organized in order, instead of using a regular array, maybe you want to use a heap because that's going to automatically keep that sorted for you and make it easier for you to use. So as you're working through whatever it is, you have a challenge at work, something's being slow. I did show, I want to show, while we're here, let me minimize this. I want to show two things, which we did. I did a simple micro time so you can see before the start time, the after time, so you can see how long it took. That's a simple way. If you know what specific place you're actually looking for, hey, is it better for me to use an array function, or is it better for me to use this array function or that array function to loop? What's better? If it's actually matters, this could be, that place, you can just put this in, run it, and get a test quick. But oftentimes you actually want to do some more profiling. So before, there are lots of tools that do profiling on your hosting service that will give you a breakdown of everything from your database, like where is the slow point from the database, on the host, on the images, all of that stuff. But if you're wanting to look for your code, XDebug has the profiling, does have profiling that you can use. It's not too crazy to set up. I have it set up for XDebug in my browser, or was trying to get it in PHP Storm, get that set up, but I wasn't getting the output correctly. So, but XDebug does have a profiler. However, it kind of structures it weird. So they suggest that you use the kcache grind tool to read the file that it outputs, because it'll output the profiling, but it doesn't format it in a very readable way. So, for example, where's mine? Here's where I did my tree traversal, and I put through my XDebug profile equals 1, so I'm actually running that profile, and that's back in my code. Tree traversal, we looked at these. So right now I was outputting the level order. And is it not there? It's not. There it is. Okay. Okay. So here is that Qcache. I have a Mac, so I installed it here. Homebrew, Qcache grind. I did the brew install, and now in my terminal, I just ran this, and it opened QCache. And now I'm going to my xdebug folder, and there you can start to see where what things took time, how many times it was called, and you have a little bit more of some visuals here. So if you're looking to do some more profiling on things to see how it runs, more than just going, oh, I waited for a long time, that was too slow, and you want some actual numbers, you can do, if you want to profile your whole file, especially, or maybe your script hits multiple files and you want the whole script to, that whole, all of the code evaluated, you're using a profiling tool, xdebug, with the QCache grind is a great way to do it. And if you just want a simple, see how it goes, I just want to test this specific part, that's what I did with my heap. And I just did the before time and the after time, subtracted them to see how long it took. So those are your two options. There are multiple options. Those are the two best options depending on what you want to do. Something really quick just to test this one little part. Sure, the microtime works. If you want to profile your whole script like you would run on any other test, doing the xdebug and QCache grind for the display will give you a lot more functionality. And you can test it out and play around and see if it's worth it. If you're talking about 0.5 seconds versus 0.6 seconds, and one of them is a lot easier to read, go with the one that's easier to read. You're not changing a lot of time. Unless it's happening, unless, that gets multiplied because it happens 10,000 times. Who knows? Yeah, so just, again, be careful of the trade-offs. Don't try to optimize something that doesn't actually need to be optimized. But if you're looking to solve a problem, whether that's a HackerRank or LeetCode problem, or if you're trying to solve a problem at work with something that is being slow, then definitely look into profiling and different data types in PHP that might be more useful. Okay, I'm going to stop sharing. If anybody else wants to jump in and say hi, anybody's welcome to jump in and say hi. I don't think I saw any other questions in the chat. I like HackerRank. I think that one to me was a lot more fun. I like solving the problems. And I like the way is the visual, the display of it is better for me and works. So I think it's fun. I'd encourage people to play around with it. But hi, Derek. Hi, Mark. Hi, Bobby. Hi, Chris.
So I guess my question for you would be, like, have you actually used a heap in like your day-to-day job?
No. Typically when I'm doing it, anything that would have been where I had to manipulate a lot of data, I would have been doing it. I had done it directly in the database layer.
Right.
So that's actually what I've done when it's come to more data, is that I've done that at the database level. Like, oh, I don't need to pull in 10 billion things into a PHP array. I'm going to filter some of that in my database before I pull it into PHP.
Right. And I guess the thought process that was going through my head is, and I learned about heaps in college and that kind of thing. So like I've heard about a lot of this kind of stuff, but like the thought process that was going through my head is usually when I'm like trying to sort through data, it's like multiple objects that came out of the database or something like that. And it's like, if you're talking about millions of objects, your problem isn't gonna just like your biggest problem isn't going to be your sorting algorithm. It's going to be that you don't have enough memory for it. You know, I mean,
right. How often are you?
You can always, memory's cheap, right? So you can always just add more memory to be able to handle that. But it's, there's probably a better way, right?
Right. And how often are you just looking at numbers like this
Right.
one? Like numbers are small, compared to a larger string or some other data structure that, if we're just doing an array of numbers and just doing something with those, it's going to be easier. It's going to be quicker already, and it's not going to store as much. But again, you're typically working on other things. So yeah, these are things that you're going to run across in the hacker ranks or things like that. We're going to challenge you with an algorithm. I think the important thing is to know that PHP is already doing a lot of this in the back. Like when your arrays in PHP are already optimized for a lot of stuff that some of the other languages don't have. And so, like if you get back to, for example, in C, PHP in the back is written in C. And so having those, it's going to have to do much more coding to get specific what's going on, where it's easy for us to just go, hey, I want an array. And it goes, oh, I want this array to be a hash. I want it to have keyed indexing instead of, just numerical indexed. Like we have that.
Yeah.
You don't have to worry about what's going on as much in the background.
True.
And so some of that is because PHP is great. But also some of it, as you were saying, is you're not often doing so much of that, and you might want to go back further. Like I was mentioning the database. Like before I bring it out of the database, I'm going to let my database do the crunching of that data before I have to do that filtering of the data in code.
Right. Well, because that's what databases are good at. That's, yeah. Yep. I was just curious, just because, like I said, I learned about all this stuff. I had to take an entire course on data structures in college, and like I've never used that. I've never used it since. Like,
Yep. But that's what I wanted people to see, that like if there's a specific data structure or you're trying to do a challenge, or somebody's questioning you about this, there is probably a data structure you could get to in PHP, but PHP's data structures are already using these under the hood a lot of time. So a lot of time you already benefit with them. Yeah. Without having to worry about it.
Yep.
But it's fun. It's sometimes fun to like challenge yourself and try something new and play with some things in HackerRank and see how it goes. And
all right. Well, my family's calling me for dinner, so I'm gonna need to go. So see you guys later.
Yep. Thanks for showing up. Thanks for your help, Mark. I appreciate you getting me working at the beginning there.
Good talk. Thank you.
Yeah.
Great talk. Thank you so much, Elaine.
Thanks. I hope it encourages somebody to play. Have some fun. And I will share some links, I suppose, to some resources. Probably best to, where do I even share that? I guess I'll share it in, I guess I can share some links just right now on, in the YouTube chat. We don't really have we need to set that up. I'm supposed to be updating the merge website anyway, so I need to make sure that we have, like, when you move it, what's our extra links or whatever on there. So
Probably makes sense to just attach it to the listing of the meeting.
Right.
So if you remember, oh, I want to go back to the algorithms one from 3 months ago, you can find that one by date or something or title, and then it's right there.
Right. Yeah, we should be able to add that to our listings, and then when they get moved, and then you can update them after the fact too. It doesn't like if I don't have the links before the fact, I can update them after the fact, but make them a little bit easier. And I definitely want to share. Ooh, this one was good. Binary tree implementation. It's nice when you can find actual resources for stuff in PHP instead of like, you're like, okay, well, how do I translate that to PHP? And so I appreciated having some good PHP resources. And Xdebug in PHP Storm for profiling. There we go. I think that is about. Oh, did I share the data structures? Did I share the data structures? Oh yeah, I guess I might actually. I don't know if I have access to the YouTube description myself. Maybe we could link to. We could definitely add a link to the website with stuff too. But yeah, we should. Yeah. Okay, I don't think I did the data structures. So there's the PHP data structures. Okay. Any other links I missed? Okay, well, we'll get it figured out and get more information for people up there. And hey, if people want to play, hit me up. No links came through here. That's weird. Do people see them on YouTube? Because I posted a bunch of links on YouTube. Do you see my links on YouTube?
The links, I mean, I don't have an open.
Mm-hmm. That's.
You could get him mad.
Okay, well, I will somehow get them into the description, and I will definitely have it on the website. So I will put all of the links on the website. I will actually have that much done tonight because I can. Well, okay, I can't guarantee because I'm going to have somebody else PR it. But I'll put links on the website, and you can definitely go there soon and find find all the links that I was trying to share on YouTube, but it doesn't like me to link out or something. Okay. Well, thank you all again, and I look forward to seeing you next month, May 8th, right before TAC. Don't forget, PHP TAC coming up. Okay. Talk to you later.
Everybody, thanks.